right, this is our unit on functions. Learning target 2 is evaluate relationship in function notation through substitution and by graph. So we're going to get into kind of the tricky part of functions, and that's the hardest part of all this is just accepting the change of function notation. Function notation is a notation where a function is named with a letter and the input is shown in parentheses after the function name. So like instead of y equals 2x plus 4, we're now going to write that as either f of x equals 2x plus 4. And the reason for this is that then we can write, let's say we had an equation y equals 2x plus 4 and an equation y equals 1/2 x plus 6. Okay, we've had that before, and our next unit is on systems of equations, and you're going to have multiple equations. So instead of, it gets confusing when you have to talk about this is y1 and this is y2, and you just use the same letters again and again to describe it. So now function notation makes it nice because we would call this then like h of x. So we give these functions a name instead of just using y equals all the time, okay? This is still y, basically. So the new y is now f of x, or y is now h of x, okay? There's a new name. That's all function notation is a new name, okay? And then the x value sometimes when we're asked, okay, so this would be an example of what is y when x is 3. Okay, so before, if I would have said calculate y when x is 3, then you would have put 3 in here and crossed out the x and calculated that. So now we write that as f of 3. So f of 3 is literally that same thing. It's 2 times, instead of x, we're going to write 3 plus 4. So that would be 2 times 3 is 6 plus 4, so f of 3 is 10. So f of 3 is 10, okay? You'll also be asked things like find f of 14, or not f of 14, find f of x equals 14, or find x when f of x equals 14. Well, when f of x equals 14, that just means we put in then 14 equals 2x plus 4. And we've done this before. That's when we're just going to subtract 4 from both sides. And then we have 10 equals 2x, divide by 2, and 5 equals x. So f of x when x equals, or when f of x equals 14, x equals 5. Okay? That's about the only confusing part, is instead of saying find x when y is 14, now we're going to say when f of x is 14. So that's function notation. All right, that's function notation when we're using equations. We can also talk about function notation when using graphs. So we have this graph here, and again, this graph doesn't really have an equation. So this is another example of when function notation is good. I mean, it would have an equation from here to here, and then from here to here, and then from here to here. But it's kind of all over the place. So we can just call this line, or this segment, or segment of lines, we can call it f of x. Okay, so there's a function here called f of x. We know it's a function because it passes the vertical line test. But then we can answer questions. So we can answer things like, what is f of 4? Okay, well, f of 4 would be when x is 4. So f of 4, we go to where x is 4. We look, f of 4 would be 1. Okay, you can also look at, then it says check that f of 2 is 4. So f of 2 is an x value, so f of 2, we go up, then the graph is at 4. So f of 2 is 4. Can you find the two x values for when f of x, so when f of x is 1. It's kind of nice because when x is actually, you can see x, then we know we're looking for x. When x is replaced, then we know we're looking for the output. So here we're looking for, and it's easier to talk about inputs and outputs. Maybe that's what I should have been talking about in the last one. So when f of x is 5, when our output is 1, excuse me, not 5, 1. When our output is 1, then that's going to go here. Our input is 4, so x equals 4. And we can see it crosses there again. X equals like 9.3 or something like that, an estimate. Okay. It also asks for what's the value of f of 6. Well, that's gonna, we're given an input. What's the output? 6 is here. We go up to our output would be 2. Okay. So that's kind of just a gist on using function notation. It's all about inputs and inputs and outputs. Okay. X values are the inputs, but now f of x values are the outputs. That's how it changes. So before class, try to use the graph to answer the following questions, and we will talk about that in class.